ambitions are to establish a pan-European network of DIHs, now transformed into RIMA Network Alliance, and the creation of robotics applications in inspection and maintenance, linking technological excellence with industrial sectors that can benefit from it.
The RIMA network for us is an enabling factor. It's something that we need in order to perform what we are actually doing. A project like RIMA is really assisting not only financially, but also technically in developing our solution.
It's an opportunity to network with partners and companies with broad expertise in this field. And it also has opportunities for funding research projects.
This particular project gives us the opportunity to deliver our services more safe and more efficient.
RIMA supported, financially and technically, 50 cross-border experiments involving European small and medium-sized enterprises through 2 open calls, with a total amount of 8.1 million euros. Experiments were grouped into sectors, with sector representatives that served as guides and dialogue facilitators with higher institutions by fostering leveraging access to DIHs by industries. Through services, SMEs were able to receive mentoring support on technical and business levels, access high-quality infrastructures, demonstrators and testing facilities for advanced robotic technologies, and engage in network opportunities, disseminating their activities.
We are receiving a variety of services. They're very useful in the sense that we are a relatively small company and we don't have the resources to educate or perform activities that are well out of the scope of our main business.
This and other technology transfer experiments and technology demonstrators have fit in at least one of the following RIMA target use domains that are rail infrastructure, including local transport systems such as trams, covering track and trackside equipment and stations. Robotics is also attracting more and more attention in ports, airports, and interchanges. Some experiments in this field are NEMO, a technical solution for autonomous data collection and seabed monitoring for harbor basins and quays. OPER, an autonomous robot for underwater asset inspections. RoboHop, an agile robotic crawler with couplant-free inspection capability.
We are developing a solution for the shipping industry for inspection in confined spaces, areas where, let's say, the competitor devices, which are drones. Drones are easier to deploy, but they are limited in their capacity to take measurements, whereas our solution is a tetherless solution with a crawler that magnetically attaches on the surface of typical ships and can perform thickness gauging, which is very important.
Extraction, refining, and distribution, including offshore infrastructure and decommissioning, is important in oil and gas plants. The needs of robotics are huge due to the budget involved in these activities and the safety and environmental concerns. For this sector, it would be good to highlight MIMIC Project, a remote platform for inspecting and maintaining industrial infrastructures with safety and accuracy. Energy generation and distribution includes onshore and offshore plants with pipes, tanks, boilers, and other structures to be inspected. The maintenance of solar panels and solar thermal collectors has an important influence on the generation. For energy distribution, it involves electrical power lines and substations. Aero Defect Scan, an aerial robot for the automated detection in solar panels. Spark Inspection and Maintenance, an affordable and innovative multi-robot system for solar panels with autonomous cleaning and inspection. RoboClean, a robotized cleaning system through ultrasonic waves at CSP and photovoltaic plants. AutoBolt, an autonomous bolt pretension measurement for wind turbines using EMAT technology. SBID, a hydrogen drone for long-distance asset inspections. Drone 4PV, an automated drone with AI for optimizing maintenance planning. Autodrone, a hydropower inspection drone by autonomous navigation. T-Iris, a twin-integrated solution to tackle the complexity of robotic inspection integration in industrial sites. Bladebug, an adaptable and universal robotic system for wind turbine maintenance.
The company Bladebug has a product that they also call Bladebug, and that's a robot that can be deployed onto a windmill wing, and it can walk around and be a stable platform for different sensors on it.
In nuclear energy, robotics technologies have a key role to play in extended life maintenance programs, in the decommissioning of legacy facilities or of currently active reactors to keep them safe and reliable. Some of our experiments in the field are Realigned, a robotic solution for reporting dosimetry in the real images of the radioactive environments. Magic Lancer 2, an innovative robotic system for non-destructive examination of reactor pressure vessel. Road and civil infrastructures, including bridges and tunnels, have important inspection needs with very high costs. Robotic inspection is also needed for bridges with large volumes of traffic, where inspection-based traffic interference should be avoided as much as possible. Some of our experiments are Aid4's Build, an autonomous robotic UAV for the precise indoor inspection of building assets. InspectRail, a project to develop autonomous mobile robots for inspection of railway lines. Map4Cat, a mapping drone system that works together with a mapping car to deliver simultaneous air-ground 3D geodata. CQMR, a robot that can measure the quality of coatings in the future even more safely and cost-effectively, while CQM also enables predictive maintenance. GreenBee, a combined solution of unmanned aerial vehicle with AI and machine learning for road infrastructure inspection. Clean water storage and distribution, not forgetting waste infrastructure, additionally involve the inspection of pipes, tanks, and other elements. Robotics is interesting for internal inspection or even repairing of small diameter pipes, as well as the inspection of big infrastructures, covering dams and reservoirs of natural water resources, as our RIMA experiments have proved. InnoWatt, a drone with 3D localization and mapping capabilities for water treatment plants indoor inspection.
ScoutDI, we develop, manufacture and sell a complete solution for inspection of confined spaces. And our solution consists of a drone that is especially designed to fly in dark confined spaces where you typically don't have GPS coverage. Targets are, for example, cargo tanks on ships or storage tanks in oil and gas. Other types of indoor infrastructure, for example, water treatment plants. We also have a cloud solution to handle all the inspection data from the drone. So it stores the inspection data and you can analyze it and create inspection reports.
PipeEye, a remotely operated vehicle for interior water pipeline inspection. Terrapin, a robotic underground water pipe inspector.
The main impact of the project is mainly more knowledge about the field, indoor inspection, what kind of technology is available and might be available in the future, but also our clients' needs. It turns out that the client had needs that we didn't know before, so the impact is more knowledge and probably more understanding of the market in several parts of Europe.
DIHs and sectorial facilitators assisted experiments to create linkages with other application experiments, technology providers and system integrators to understand what the challenges were, how to optimize the solutions, and which advanced technologies were best suited to impact the markets.
I think that robotics for inspection and maintenance is even more important due to the energy crisis and the threats that we see towards our infrastructure. So I think we need to level up our inspection and maintenance activities to safeguard our assets and our infrastructure in Europe.
See the future of robotics and maintenance in Europe being more of it. We're going to use more and more robots. We're going to use more and more AI. So I see that the robots are going to take in to the forest. They're going to get out in the field along with the farmer. They're going to be more and more a supplement to already standardized tools and methods out there. We see this all the time, and we see also that safety and efficiency is a big gain that we get from the robots.
A RIMA alliance will be a way to turn experiments into fully independent value propositions when giving firm steps towards the market after the RIMA network project ends. Their autonomy is our own success, as they become fully prepared for a challenging and motivating future to dive into by themselves. If you want to follow this patch and bring your robotic application to the next level, contact the RIMA Network Alliance now and start walking the path towards the future of inspection and maintenance in the EU.
So all of the experiments that we supported financially in RIMA were able to create new products or new services, satisfying also the objectives of users that supported them initially. And most of them were also able to raise funds, which represent an amount superior to the amount that we distributed to these SMEs. So it's also extremely satisfying for all parties.